So this car has been having some difficulty with vapor lock. Just to explain what the problem is here, vapor lock is when the engine gets hot and the carburetor or parts of the fuel system will vaporize. The fuel will vaporize and it will lose its ability to pump. And so you lose, the carburetor starves and it just won't run. The car will run fine when you start it cold and you drive it for a while, but after the exhaust manifold heats up and then you park it, let's say you go to the store to pick up some stuff, and you come out from the store and it's been sitting there idle and there's no cooling from any of the fans, and the exhaust manifold, even though I wrapped it, it gives off heat, which causes the carburetor, which now that it's stopped and there's no air flowing through it, it gets really hot and it will cook off the fuel that's in the bowl. And once that happens, you have to wait until it cools down so that the float will open up, and then the rest of the fuel system can start to feed fuel into the system. It'll start right up after, waiting for half an hour, 20 minutes until everything cools off, and then the car can run. So what we're going to do today, and the purpose of this video, is to show you how to make a custom heat shield if you have a side draft carburetor. Now, the original vehicle came with the dual SU carburetors, and I still have those. Here is the original manufactured heat shield. So it's quite obvious that it was part of the design to put a heat shield in there. This heat shield would go in kind of like this, and the carburetors would come off with the little spacer right here. This little dent is for the center of the exhaust, and it would vent the heat sort of at an angle so that it would come up through kind of like right in here. So I'm going to try to, it's kind of a hideous looking design and it doesn't quite fit with the Weber, but I'm going to use that as a roadmap, let's say, to design a custom heat shield. Also, I don't like the regular steel that they used. That would be something that would become rusty. And on the original, I'll go back to the original. They had these asbestos plates in here on the edges, one on either side. They were kind of clipped in. Asbestos is, as we know, persona non grata. Nobody wants asbestos in their car anymore, so I won't be using these asbestos plates. But I'm going to see if I can find a way to shield it so that we can reduce the amount of heat that gets passed through that metal. Also, I have a scrap piece of very thin stainless steel. So let's see if we can machine that stainless steel so that it looks good, and put some ridges on it so that it becomes nice and rigid and doesn't flop around. And we'll get that thing mounted in here so that it doesn't have as much of a heat problem anymore. So let's go ahead and get started. At the beginning of that, let me show you what my physical constraints are underneath this carburetor. So down underneath the Weber, you see the manifold is the lowest part. This right here is the lowest part, and so this bolt right here is probably the best place. There's two of these, one on either side. The best place for me to mount a heat shield. The problem with that is that the heat shield needs to kind of go this way. So if I put something in here and I expect to tighten that bolt, I need to have a way to tighten that. And so it adds a little twist. So we'll probably connect it and then drop down about a half an inch so we can get room for a socket, and then we'll move this tray. I don't think I'm going to go horizontal. I think I'll go diagonal. That'll allow the updraft of the airflow to move the air through the center right here. So that's the plan. I'm going to go up underneath this carburetor and give it a little bit of a heat gap so that it doesn't get all hot. So in order to prove that this works, I want to reproduce the ill effects. So I'm going to start the car up and let it run for a while, get it nice and hot, and I'm going to cause a vapor lock on purpose, and then I'll show you what it is, what the symptoms are, and then we'll do the heat shield, and then we'll try to cause the vapor lock again to see if the heat shield is doing what it's supposed to do. I'll go get my infrared thermometer, and we'll take some measurements once it's all vapor locked, so you can get an idea of what we're trying to avoid. All right, so here, let's take a quick baseline. This is just started up, sitting here idle. Carburetor is 106. The top of the carburetor is 75. The exhaust manifold is 140 roughly, and growing. So let's get it nice and hot. Once the fan starts to kick on, then we'll know that the thermostat's open and the engine has reached its peak heat. So we'll check back in on that, and we'll take another measurement. You can see the cooling fans have engaged. It means that the engine block should be getting pretty hot. Thermostat's open. We got about 190 degrees at the thermostat housing. We're really getting up there on the exhaust manifold. 280. Pretty hot. So this is the throat on the carburetor. You can see 132. The base of the carburetor still pretty good. It's 96. Again, this is where the fuel is inside the bowl. You can measure the temperature of the bowl right here. That's not too hot. Get a little warmer down here, but as long as the fuel keeps moving and it keeps have air flowing through it, it'll cool it down. I'm gonna rev it a little bit for a little while and see if we can get this exhaust manifold nice and toasty. All right, so it's been cooking for a while. Yeah, we got that exhaust manifold really high. 450. Carburetor is hanging around the 200s. The bowl of the carburetor is still around 100. All right, let's go ahead and shut it off and watch that carburetor temperature change. All right, so I got the lid closed, the hood closed. I'm going to simulate myself walking around in the store for 20 minutes. I'm going to come back out here, and we'll try to get this car started and see if we can get a good vapor lock. All right, a little bit of time in the store. Car won't start. No, it started to start. I think maybe I left it set too long, but let's take a measurement anyway. All right, so sitting for a little while after running it through its paces. Let's see what we get. 180. The bowl is 150. So you can see that bowl gets pretty toasty after it sits for a while. The exhaust manifold has cooled down a bit. It's under 300, but all that heat has been transferred up into the bowl, and it has evacuated the bowl. There's no fuel in there. Now we didn't let it sit for very long, so it started to refill the bowl. But the point is that's how the vacuum the vapor lock occurs. Is it gets too hot on the bowl and it boils off the fuel. So let's go ahead and get started. I'm going to go ahead and pull the carburetor off here, and we're going to get some measurements and see where we can move forward with. Alright, so just like most metal working projects, it starts with a cardboard cutout. So this template right here kind of shows me where the space is in this area for this heat shield. Now, I don't know if I want this heat shield to be completely flat. I think it needs to be at an angle so that you know, the heat can obviously go up and come out this area. You don't want it to well up in there. It's just gonna, you know, it's just gonna do this. It's gonna get hot. The other thing is, being mounted just right here, it'll be floppy, right? So it has to be mounted on another counterpoint. So I'm going to make it mount back here on this piece of the firewall. We're going to put a little stud up, and it will connect into here. I think what we end up it's not going to be sharp edges. I think I'll make a bit more graceful curves coming around here, so it looks a little nicer, kind of like a round edge right here. And I do like this extra section over here because it'll protect the fuel lines from heat as well. So I think that's what we're going at. Now, obviously, looking at this, the carburetor doesn't get bolted on top of the heat shield. The carburetor goes into here, and it has a gasket that seals it, and then this goes on, and then the nuts that hold the carburetor on will go on. This little section of the downpipe, or the exhaust manifold, is kind of a problem. It kind of pokes out in this area right in here, so this is going to be kind of beveled like this. So there'll be a bit of a curve going this way as well. So we'll see how much we can get out of this thing. Let's put this in place and just kind of lay the carburetor into place and see what it looks like with the carb in place. All right, so with the carburetor in place, you can see the area that it's going to protect from the updraft of the heat, and see how it's going to give you plenty of room to still get in here and tighten those screws down. It's not going to be right up against the carburetor. And there's the connection to the firewall. All right, so let's take a look at the piece of metal that we're going to use to make this thing. Nothing goes to waste around this shop. This is an old door off of a barbecue that we purchased. Nice piece of stainless steel, so I kept it when we trashed the barbecue. But here, this is the cool thing. On the inside, it's like a mirror finish. So that'll look really nice facing upward. You'll be able to see the bottom of the carburetor, which is all polished, and this will give you a nice view of yourself, probably, because it's going to be a bit of an angle. So anyway, let's get this thing cut up and shaped and see what it looks like when we mock it up. All right, so the back side of this, I purchased some heat insulating tape. This will insulate it up to 2,000 degrees, and this will help to keep the temperature from moving just through this plate and radiating through the plate. So hopefully that gives us a really good insulation. The edges, it's a tape. It has a self-adhesive tape backing. I'll put a link to the description on what the product was that I purchased. But it's tape, right? So I went ahead and folded the ends off around it just to make sure that if the tape ever gave up, it would still have something to hold it down. So let's go ahead and get this thing all mounted up and do some testing. All right, well, there you go. It's all set in place. Has a little area for it to be connected right back here. I'm going to put a machine screw through that into the firewall, and you can see I haven't bolted it in, but the little holes connect right there on the manifold side, right on this side of the carburetor. So, all right, there we go. Got it all back together again. You can see the heat shield in place. I don't think I have to worry too much about this little area right in here because the heat goes up, not out. And by the time it gets to here, it's not going to affect the carburetor. Everything looks clean. Alright, Alright, let's get this thing warmed up and get some temperature. Let's get a quick baseline. Alright, the heat shield itself, 81 degrees. Carburetor, 80 degrees. The bowl, 73. It's starting to get hot. Starting to get warmed up. Alright, I'm going to let it idle for a little while and then we'll come back and have a look. Alright, so I got the cooling fans involved. So the thermostat temperature, about 200. The manifold temperature, just under 400, 350. The heat shield is staying at about 100, and the carburetor right about the same. The float or the bowl is well under 100. Get it in the right spot. At about 100. I'd have to say it's pretty good. I mean, the manifold itself is going to get kind of hot, and it's connected to it. I don't think it's going to boil off the fuel. Now, let's get it nice and hot, and then we'll see if we can get a vapor lock. Alright, so we heated it up, and with the cooling fan still running, I turned the engine off like I'd stopped at a store. Went in, had a drink of water, kind of chummed around for a while. Now I'm going to come out and take some measurements. Let's lift the lid. Alright, so assuming I was at the store, the heat barrier is 129. The carburetor is 150, and the carburetor bowl is 130. I don't think I accomplished what I wanted to accomplish. The exhaust manifold still 300. Let's see if the car will start. Alright, well, the fuel pump is ticking, so that's a good sign. Yeah. Oh, still got a vapor lock. Well, that's a bummer. All that work and it didn't accomplish what I wanted to. I think that the problem is just that the intake manifold transmits too much heat from the head once it's set there, and I don't think there's any amount of thermal protection that you can get to protect that. On the twin SUs, they have a plastic barrier between the carburetor and the intake manifold, and that probably would be enough to get it to cause a bit of a heat barrier. And but the Webers don't have that. It's connected directly to an aluminum intake manifold. So this effort was fruitless. It was kind of fun to do, and I know that the carburetor itself is protected while the engine's running from heat, but the radiant heat off of that intake manifold, as it's connected right to the exhaust manifold, right in the same place of the head there, it's just too close. I don't know what to say. Yep, it's a vapor lock. Alright, so this project was not entirely successful, but it did point out some flaws in the installation of this Weber carburetor. First of all, I don't know if you can see, right here where the carburetor is connected to the manifold, and the manifold is really hot. This manifold gets really hot, and so you need to have what they call a phenolic insulator right here. It's like a little spacer, about 15 millimeters. It's just a, well, here is the spacer from the original SU carburetors. It's quite a beefy spacer, but it's a really dense material in a poor transmitter of heat. And so the idea here is that there's a piece missing in this installation. So we're going to get a phenolic insulator, and we're going to install it right in here, and that will separate the carburetor from the manifold. The manifold can get as hot as it wants, and that insulator will keep the carburetor from getting hot. Now, if I'm touching this is almost cold. This is the new heatsink. It really does insulate very well any of the heat from the manifold right there, the exhaust manifold. So it's not radiant heat that is causing the carburetor to get so hot, because this carburetor is still very, very warm. It's too hot to hold, very hot to the touch. And the reason why is not because of the thermal radiant heat, but from the heat coming from the engine block through the intake manifold. So we need to put that phenolic spacer in there to get it to keep from transmitting that heat when we park the car at the store. It takes a while for it to cool down too, so it's definitely something that we need to address. Now, in order for me to put that spacer in, it's going to require some adjustments here, because I don't have a whole lot of room in here. And if we put that spacer in, it's going to move everything that direction about 5 millimeters, maybe a little bit more. So we're going to order those parts and make those adjustments as necessary when we get to that point. I think what I'll do is I'll just shim off the bottom down here, and hopefully that doesn't cause any problems with the airflow. But that won't be that difficult to take care of. So that's it for the video today. I'm sorry that there's not a happy ending, but part 2, when we get the new parts in, we'll put that insulator in there, and we'll go through all the tests that we did before, where we were able to measure the temperature while it's running, and then park it for a while, and then measure the temperature and see if we can get the car to start. But as it is, it's really difficult to drive this vehicle when it vapor locks every time that you stop somewhere. So aside from just going out for quick little jaunts and having fun and putting it back in the garage, I really can't use it much for going out to the store and such. So make sure you follow next week. Follow on next week. We'll get those parts in. We'll put this insulator in there. I'm thinking maybe I'll have to get some longer studs because that insulator is gonna it's gonna cause some complications. So anyway, that's all I have for you this week. Make sure you check back and follow to see how it comes out.